Let us see chapter number 13, lecture number 9. Last time we were discussing exercise 13.3. Among first, second, third. Fourth one is also solved. First, second part and third part. Second part is solved, first part is given for homework. Third one is also solved, but some mistake is there. So today I would like to see once again. Now see here. Fourth one says that if we toss one balance point, how many times? 4 times. Then what is sample space is? If it was 1 time, then HT. So 4 times it comes out HT cross HT cross HT. How many times? 4 times. Is it clear? How many observations are there? 16. 2 to the 4 to the 8 to the 16. Now, random variable x from h12 is defined as x of u is equal to number of heads in u, where u belongs to S. We want probability distribution of number of heads when one balance point tossed 4 times. What is range set? And therefore range set of x. 4 times number of heads. Either that means at most 4 heads are there. 4 or less. That is number of heads 0, 1, 2, 3, 4. This is the range set. Now we have to find probability of every element in range set. What is probability of 0? That means no heads are there. Only one observation. Which one? T, 4 times T. That comes out 1 by 16. Now let us see. 1 heads are there. How many observations are there that consist 1 head? T, H, T, H, That means you can add any order, no problem. Head obtained in 4th trial, head obtained in 3rd trial, head obtained in 2nd trial, head obtained in 1st trial. You can write any order because this set is represented in a listing method. So order is not necessary. How many observations are there? 4. So that comes 2 by 16. Now let us say how many observations consisting 2 heads. See, mistake is done here. Last time only see this example, but one mistake is done here. See here. 2 heads are there. One first and second trial. T, H, first and third and fourth trial. H, first and third trial. T, H, second and fourth trial. H, 1, 2, 3, 4, 5 and 6 observations are there. Last time we were written as a 5. So that is the print mistake, that is the mistake done by me. So today I would like to solve that thing. So how many observations are there? 6. 6 by 16. Now let us see number of 3 heads are there. How many observations are there? First 3 heads. HDH, HDHH, THH. How many observations are there? 1, 2, 3, 4. That probability is 4 by 16. Next, 4 heads are there. We know that only one outcome that consists 4 outcomes as a head. So that is 1 by 16. And therefore, what is probability distribution of X is as follows. X is equal to X, P of X is equal to X, 0, 1, 2, 3, 4, 0 heads, 1 by 16, 1 heads, 4 by 16, 2 heads, 6 by 16, 3 heads, 4 by 16, 1 by 16. 4, 6 plus 4, 10 plus 4, 15 plus 1 plus 1, 16 by 16. See, last time mistake is done here 5, here also 5 written. So that two thing is mistake done by me. That thing already solved. So please cancel that sum and consider this one. This one is the probability distribution of number of heads whenever one balance coin goes 4 times. Clear to everybody? Yes. Now, see, question number 5 and 6. Question number 5 and 6. We are not going to solve as per this formula, but we would like to solve them based on binomial distribution. That thing we are going to see after this exercise. That based on binomial distribution. If of course we can solve with help of this method also, but so that method is so lengthy. So I would like to solve this example number 5 and 6 in exercise before exercise 13.4. Yeah. So let us leave that part for that thing. Now example number 7. See, example number 7 says that a balanced coin is tossed, probability of getting head is 3 times the probability of getting tails. The chances of head is 3 times to compare with the tail. Usually whenever the balanced die is given to us, then only 2 possibility, 50-50% chances that to getting head or tail. But when you are unbalanced die, probability of getting head or toss of unbalanced coin, not die, sorry, not unbalanced coin is 3 times to getting tails. 3 times P of T. That is given to us. Usually when balanced die or unbalanced die, usually balanced coin or unbalanced coin toss once, then either head force or tail force. Only difference is between their probabilities. But we know that on a toss of one balanced or unbalanced coin, event induced, that is either head obtains or tail obtains, that two events are mutually exclusive and exist. So sum of their probability is 1. As A intersection T is equal to null set and H union D is equal to S, P of H plus P of T is equal to 1. Now replace value, and therefore 3 times P of T plus P of T is equal to 1. Say result number 1. Say by 1. So what we get? And therefore 4 P of T is equal to 1. So P of T is equal to 1 by 4. So by 1. And therefore by 1. What is P of H? 3 times P of T is nothing but 3 by 4. Now that point, unbalanced coin toss 2 times. If unbalanced coin or unbalanced coin toss 2 times, then we know that what is sample space? HH, HT, TH, TT. Now we want probability distribution of getting heads when that unbalanced coin toss 2 times. Now see, what is now we have to define. Now x from S to R, x of u is equal to number of heads in U. U belongs to S. Yes or no? Yes, that is given to us in example number 7. So what is range set? It is tossed 2 times, at most 2 heads are there. And therefore range of x is equal to nothing but at most 2 means 0, 1. Now we need to find probability. What is P of 0 is nothing but both are TT. On first trial it is tail as well as at second trial is also tail. 1 by 4, 1 by 4. That comes out 1 by 16. 1 head. No head means P of TT. 1 head. P of HT. P of HT. That means head on first trial, tail on second trial. Or tail on first trial, head on second trial. Or means plus. Now HT and TH are mutually exclusive, so there is plus. Means on first trial it is head. For head 3 pi. Second trial is 8. So 1 by. Plus first trial 10. 1 by. First trial, second trial है 3 pi. What is total? 6 by 16. Yes or no? Yes. Now, not 16. Of course, yes, yes. 4 to the 16, 16. 3 by 4, 1 by 4. Now see. 3 times or 2 times? 2 times. Now what is P of 2? 2 heads are there. P of H. 2 heads are there. First head as well as second head. First head is 3 by 4, second is 3 by 4. 9 by 16. Observe that probability of P of 0 plus P of 1 plus P of 2 should be 1. 1 by 16, 6 by 16, 9 by 16. 9 plus 1, 10 plus 16. And therefore what is probability distribution? And therefore probability distribution of X is as follows. Yes, what is that? It's nothing but, sorry, X is equal to X. P of X is equal. What are the elements in range set of X? 0, 1, 0, 1, 2. What is P of 0? 1 by 16. Then P of 2, 6 by 16. 9 by 16. Now see, question number 8. Now let us see question number 8. Probability of distribution of random variable X is given to us. Probability distribution of random variable X is given to us in tabular form. And we want some values of K as well as some probabilities. Let us see question number 9. Exercise 13.4. Sorry, question number 8. There is given that probability distribution. What is given that? Probability distribution. Probability distribution of random variable X is X is equal to X, P of X is equal to 0, 1, 2, 3, 4, 5, 6, 7. These numbers are K, 2K, 2K, 3K, K square, 2K square, 7K square plus K. Then find out K and answer some remaining 4 questions we have to answer. Among first one is to find out K. Now see. We know that is a probability distribution means here sum of this probability I is equal to 0 to 7, P of I is equal to 1. All probabilities should be non-negative as well as sum of their probability is 1. So this is this thing. And therefore, what we get? 0 plus K plus 2K plus 2K plus 3K plus K square plus 2K square plus 7K square plus K is equal to 1. Sum of this 8 probability is 1 as it is probability distribution. Now add it or simplify it. 7K square plus 2K square, 7K square plus 2K square, 2K square is 1 plus K square is also there. 7K square plus 2K square plus K square, 10K square, 3 plus 2 5 plus 2 7 plus 1 8 plus 1 9. 9. Take minus 1 on this side is equal to 0. So what we get? 10K square plus 9K minus 1 is equal to 0. Dear friends, this tabular form probability distribution is given. Probability is given in terms of one unknown quantity. First of all, we want that unknown quantity. And we can obtain it as per definition of probability distribution. All probabilities should be not negative, but without value of K, we are not able to judge whether it is positive or negative. So first of all, we need to find value of K. Use second property. Sum of all these probabilities is 1 as per probability distribution of some random variable X. So ready to get this one? Now quadratic form is that simplified. 10K square plus 10K minus K minus 1 equal to 0. 10K common, K plus 1 minus 1 common, K plus 1 is equal to 0. K plus 1, 10K minus 1 is equal to 0. And so we get K is equal to minus 1 or K is equal to 1 by 2. Two possibilities are there. But natural negative is not there. Check any one of them. For K is equal to minus 1, what is P of 1? K is minus 1 less than 0. And it's not possible. Why? Because probability should be non-negative. So definitely K is not equal to minus 1 and therefore K is equal to 1 by K. So this is the answer of first question. Okay. Second question, what they want? They want P of X less than 3. P of X less than 3. See the table. X less than 3 means what? 0, 1, 2 is equal to P of 0 plus P of 1 plus P of 2. What is P of 0? 0, P of 1, K, P of 2, 2K, that is equal to 3K, that is 3 by 10. Yes or no? 0K, 2K. Second one we want P of X, third one. P P of x greater than 6. Observe the table. P of x greater than 6 means this side. Which one? P of 7. And that is 7k square plus k. 7 by 100 plus 1 by 10. So 10 by 100. So that is equal to 17 by 100. That is equal to 0.17. That is P of x greater than 6. Last one, fourth one. What we want to answer? P of 0 less than x less than 3. In between P of 0 and P of 3, which two of the versions are there? 1 and 2. So that is equal to P of 1 plus P of 2. What is probability of P of 1? See there, k. What is probability of P of 2? 2k. That is equal to 3k. What is k? 1 by k. So that comes out 3 by k. Okay. See, up to example number 7, we are obtaining probability distribution. In question number 8, probability distribution is given to us. We want to answer some question based on probability distribution. See, whenever probability distribution is given to us, then keep two things in mind. Probability of every event should be non-negative. First thing. And second one, yes, please tell me. Yes, sum of all probability is 1. There. So that thing is easy. And very easy. Finding value of k. Whenever two possibilities are there, 1. Here it is given that 7k square plus k likewise. They can like here 2 minus 3k also. And if you get the both value positive, even though you need to check it. For k is equal to 1 by 10, every probability is equal to greater than 0, yes or no? Here only two possibilities are there. This possibility is not possible means this possibility is there. So we are not checking it. But we can check it. K is equal to 10, every positive is there. Now, next question number 9. Of course, probability distribution is given, but it is given in terms of functional group. That means in terms of function it is given that. Question number 9. Is it clear? Here, let us see. I hope that you get it. Now, question number 9. The probability distribution of some random variable x is P of x is equal to k, 2k, 3k and 0. X is equal to 0. X is equal to 1. X is equal to 2. And otherwise. That means in remaining possibility it is 0. Once again, we have to find k and we have to answer some question based on that probability distribution. What is the difference between previous sum and this one? Here, see, it is given in functional form. So let us write it in tabular form. Here, probability distribution of random variable x is as follows. It is given in tabular form also. Here, what we have to write? X is equal to x. P of x is equal to x. 0, 1, 2. Otherwise, see that we have to mention. 0 then k, 2k, 3k and 0. So same as to previous one. Find out k. Here P of 0 plus P of 1 plus P of 2. Is it need to write this one? Yes, it is need to write it. P of otherwise. That is equal to 1. So I add it here, and therefore k plus 2k plus 3k plus 0 is equal to 1. So what we get? And therefore 6k is equal to 1. And therefore k is equal to 1 by 6. K is equal to 1 by 6 is that. Next they want P of x less than 2. Means what? What they want? P of x less than 2. Means P of 0 plus P of 1. I hope now you are able to do rest of things. P of x less than or equal to 2 means what? Yes? P of 0 plus P of 1 plus P of 2. And at last they want P of x greater than or equal to 2. That is P of 2 plus P of otherwise greater than 2. Greater than or equal to 2 or more, less than or equal to 2 or less, only less than 2 this one. Now you can replace value here and you get the answer. So I am leaving that one for you. Now question number 10. I hope that you get at this thing. So let us see question number 10. Question number 10 says that find the mean number of hairs in 3 toss of a fair coin, balanced coin, unbased coin. Clear? See here. See, from 11th science we know that the sample space associated with toss of one fair coin 3 times. What is that sample space? Example number 10 is sample space associated with tossing 3 balance. Is what is this? Yes, please tell me. HD cross HD cross HD. What is N? N is equal to 8. You can write in that order also, you can leave through this stage also, no problem. Next, our aim is to obtain mean number, expected value we want. So number of hairs. So first of all we need to define random variable x. Now x from s to r, x of u is equal to number of hairs in u belongs to s. See here 3 balance coils tossed together. So at most 3 hands are there. 3 or less. So what is range of x? Range of x is equal to 0, 1, 2 and 3. 3 hands are there. So first of all we need to find P of 0. No hairs, only one possibility, T. What are the possible outcomes? 1 by 8. Now P of 1 head is there. So T, H, T, 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 H, H, T, T. Any other possible element? No. So that comes out 3 by 8. Now 2 heads are there. How many outcomes? Such outcomes are there. That is H, H, T, H, T, H, T, H, H. Any other possibilities are there? No. Then get 3 by 8. And at most 3 heads are there. P of 3. Only one outcome is there. So what is that? 1 by 8. Okay? Yes. And therefore, what is probability distribution? Probability distribution of random variable x is as follows. What is random variable? Number of heads. Here. So x is equal to h. P of x is equal to h. How many heads are there? At most 3. That is 0, 1, 2, and 3. What is probability here? 1 by 8, 3 by 8, 3 by 8, and 1 by 8. We want mean number of heads, and therefore mean number of head is nothing but expected value. What is its notation? Mu. What is that formula? Yes, recall that formula. Already learned that one. Yes, it is nothing but sigma xi p of xi. I running from 1 to n. So xi into p of xi, that is 0 into p of 0. 1 into p of 1, 2 into p of 2, and 3 into p of 3. Is it clear? Yes. 0 into p of 0, that is 0 by 8, 1 into 3, 3 by 8, 2 into 3, 6 by 8, plus 3 into 1, 3 by 8, that is equal to 12 by 8, 4, 3 ja, 4, 2 ja. So that is equal to 1.5. Is it clear? So, after finding probability distribution up to example number 9, what we are doing? Just we are finding probability distribution, or probability distribution is given, then some question based on that. Now question number 10 to onwards, they want mean, standard deviation or variance. Clear? See, today let us see up to this stage. Next time we are going to see more examples, because of, see, today due to some problem, computer network problem or computer problem, we are doing this one on board. It is not favorable for us. Next time we are going to see digital form. So this is the reason why today I am leaving up to this stage. Tomorrow we are going to see in that form, in the digital form. Let us see here. See, before exercise 13.4, some illustrations are given in between 13.2 and 13.4. Now, all of you are able to do that sums. So I am leaving such illustrations for you. Illustration number 24 to 29. Illustrations number 24 to 29. That is for, it is given on the same page. Find out probability distribution, or probability distribution is given, find unknown quantity and find mean and variance and standard deviation of a given random variable. That means, first of all, as per given thing we need to define, we need to find sample space, one thing. Second thing, we need to define random variable as per given condition. Third thing, we need to mention range set. Fourth one, find out probability of every member of range of random variable x according to given experiment. Likewise this one. Fifth one, put it into tabular. Okay? Then we can find mean, variance and standard deviation also. Okay? For especially this example, if we wish to find it, how we find it? See, as far as question number 10 is concerned, they only want this thing, expected value. But what is Ex square? U of x square equal that standard form. What is the formula? Sigma xi square P of xi. That is 0 square P of 0. 1 square P of 1. 2 square P of 2. 3 square P of 3. Now see 1 by 2 and 2. 1 by 1 square into 3. 0 square into 1, that is 0. 1 square into 3, that is 3. 2 square into 3, 4 3s are 12. Plus 3 square into 1, 9. Okay. 12 plus 9, 21 plus 3, 24 by 3. That comes up 3. So what is variance of x? Yes, recall that form. What is formula? Ex square minus E of x whole square. What is Ex square? 9 minus 9 by 4. There. 9 common 1 minus 1 by 4. That is equal to 9 into 3 by 4. 27 by 4. Then what is standard deviation? Positive square root of variance. Under root 27 by 4. 3 root 3 by 2. So this is the standard deviation also. But as per our text, they want only mean. But we can find this one also. Up to this stage. Clear? Yes? Next time we are going to see more examples. Today up to this time, up to this stage. Thank you, dear friends.